We're live. Welcome, everybody. We've got P.T. Myers here today, who's an American Associate Professor of Biology at the University of Minnesota Morris. Popularly, people know him because of his Perengular Science blog. P.T. Myers has been to Australia a couple of times, back at the Atheist Conference there. And it looks like I've got some echo. All right. Oh, I've dealt with that. Good. Welcome, P.T.
Well, hello there.
So today we're going to talk about the Science March, marching for science.
Sure, yeah.
And alternate facts and science advocacy and things like that, and science in the political sphere, whatever you want to call that at the moment.
Yeah. It's kind of an interesting and awkward time because this isn't usually what we do, but the times demand it, that what we see is a lot of frustrated people in this country who are furious at this incoming administration that just is incompetent, bumbling, stupid, wrong on everything. And one of the things they're wrong on is science. And we're suddenly faced with this problem. How does a group of scientists make their case known? We're not known for communal action of this sort. So that's why I'm kind of in favor of the March for Science. I think it's a great idea that a group of scientists actually get together and stand up for something and fight for it, and that's what's going to happen. There are people who have reservations about that, but I think they're cranky old antiquarians, and who cares what these old out-of-touch people think, says the old man ranting at his screen. There's this long history in science of pretending to be apolitical. Science has never been apolitical, but we like to pretend that we're above it all. And that means that when we get into these situations where politics is interfering with science, is trying to interfere with our apprehension of reality, we're suddenly stuck. Because you will hear these arguments all the time that, well, but then you're being a partisan political hack, and that's not what scientists... And I just want to say, yes, that's what scientists have always done, is they've always been political. They've always got political views. And they often have very strong opinions about how the world ought to be managed. Sometimes dangerously so. I would agree that scientists make really crummy politicians in many cases, but we have a cause and we should advocate for it. The march will do a couple of things. One is it will give us an opportunity to show solidarity with one another. I think that's important, just that community social aspect of it. It will let the rest of the world know that we're not all Trumpian idiots in this country, and that we're willing to fight for what's right. And then I think there's another subtle thing that's going to happen, is what I would hope was going to happen, is that everyday working scientists will realize that they can make a difference and that they need to make a difference. I live in Morris, which is a teeny tiny little town. It's way out in the middle of nowhere in Minnesota. And we have here this group called Indivisible, which is all across the country. And it's been kind of amazing because all of a sudden, all these people are getting together for these weekly meetings, and they're making an email network, and they're talking to each other, and they're saying, we've got to influence our representatives. We've got to let them know what we think. That we have a couple of Republicans here, for instance, that represent this region. And so what we've done is, for instance, they recently had a town hall, right here in Morris, and surprisingly about 100 people showed up who are all there to complain and tell these politicians, no, this is wrong. We need to do X, Y, and Z. In this case, we were focused on one issue. And I think this is also useful, is developing strategies for dealing politically with these matters. This wasn't a meeting where there was 100 people all screaming 100 different things. We met ahead of time. We said, what's an important issue that's facing this community. And it was things like a recent law that's saying we need to build these hedge strips along our rivers to prevent agricultural runoff from flowing into the water. Nice and basic, right? This is a clear-cut issue. It'd be a real advantage. It would help conserve the soil and all this kind of good stuff. And so we got up there. We had a couple of people who were ecologists who spoke about why this was important. We had people in environmental science who told us how this is effective. We actually had people who looked up the costs and made the case that, you know, it's kind of silly that we're not doing this, which is a fairly cheap solution to prevent this problem. And I was impressed because these were science types or people who favored science who were taking a very pragmatic approach to dealing with a political issue. And ultimately, I think that's the strength of what scientists would do, is we care about the real facts, not the alternative facts. So we go in there and we'll say, okay, here's the budget, here's the effects, here's the problems, let's weigh them, let's put them together and come up with a solution. And I felt like that was a very effective meeting where we actually did that. Of course, the Republican candidates just sort of shrugged it off. But I think if we keep we just have to keep the pressure on.
Yeah.
And I think everybody at this meeting came away feeling like they were effective in getting a message across. And I think that's also important, is having that kind of feedback where you've got a community that is not only organizing and planning and doing things, but is talking to each other about, hey, we could have done this better, or that was pretty good, let's do that again. It's a very constructive approach to building a new coalition that will work for science in this country.
Yes,
if only we can keep it up.
Well, that's the thing. Keeping up the steam is difficult for scientists especially, because they're so focused on doing the science that it's very difficult to sort of, I don't know, split your time between. Well, some people manage it. You seem to manage it, but not everybody can manage actually doing the science, teaching science in the meantime to actually get a wage, and then being activists as well.
Yes.
And perhaps even writing a few books. My goodness, it's tiring, right? For you guys.
Oh, yeah, no, that, you know, I mentioned earlier, I'm feeling a bit sick this past week, and I think a lot of it is simply stress, that I've got a heavy teaching load this term, and everything else is piling up on me. And so I think my immune system is trying to tell me that it's a bit overworked right now. Yeah, but this stuff happens, and you don't have a choice. We've got to deal with it.
So, I mean, like, there has been some critics amongst scientists and I guess journalists as to what could go wrong with the Science March. Do you think there's any, have you read any that you thought were sound or valid?
No, they were all crap. Actually, though, I have heard some things that concern me, and they're different from what the pundits say. You know, you often get this kind of punditry that says, "Oh, be inoffensive and don't cause trouble, don't rock the boat," and I dismiss that out of hand, because I love rocking a boat. It makes for a great ride. But what I've heard is some concerns by people I respect that, for instance, one of the things we could do wrong is focus too much on single issues. That one of the things I've seen from some people is this idea that that, for instance, there are people who are very concerned about racial representation and equality in the sciences, and in things like getting women in science equal opportunities and all this kind of good stuff. And I've actually heard people say, no, we got to focus. We got to focus on Trump. We got to focus on global warming. We got to do X, Y, and Z, and that means A, B, and C are off the table. That worries me, that attitude, because I don't think it works. They're arguing in the name of unity and not splintering the scientific community, and that kind of argument splinters the scientific community.
Mm.
Because the people who are arguing for or against things like racial discrimination have a point. It's true. It's a problem. And it concerns these people, and it should concern all of us. And for us to then say, well, no, we're not going to do that this time, is dismissive and creates real problems.
Right. So there's too many people trying to curate the sort of science march message.
Correct.
Everybody has different ideas of which causes to prioritize and put in the limelight, while the others, although they may think is valid, really, I mean, like you were saying, they may actually be sympathetic to other causes as well. It's just they don't think that there's any room for them in a public message at this stage, which could be detrimental to.
Right.
It could have negative sort of flow-on effects.
Yes, I like to compare it to the suffragette march in Washington, D.C. and I think, what was it, 1913, which, we remember now as being a great effort where these women were getting out and they were marching on the Capitol to declare that they wanted the right to vote. Good thing. That's positive. But what we also remember it for now is that, for instance, Ida Wells, a black woman, wanted to join the march, wanted her community to join the march. And people told him, no, well, you got to go to the back of the parade because we don't want to antagonize people who might be against, black equality. We're just fighting for women's equality. And that completely corrupted the march, as far as I'm concerned. All of a sudden, it became this kind of selfish deal where, if you're a white woman, you can fight for equality, but if you're anybody else, you're a second-class citizen. You go to the back of the parade, and that's what we've got going right now. Is a concern that we will have people who try to say there's one true path that we should be following, one particular cause we should be following, and I think our great strength lies in a community with diverse interests who can represent all of these causes. Because literally they all fall under the umbrella of science, because some of us scientismic people would say, everything is under the umbrella of science. But
it's all physics, right?
yeah, but I mean it's a serious concern for the scientific community. It should be. And it should be represented in this march. And I do not want to see us policing who gets to be in it. And a related thing, of course, the other part of this is, we want people who are non-scientists to be on our side too. We want them in the march. This shouldn't be something where people with professional degrees are the only ones allowed, and that's not what they want to do right now. That's good, but everybody should have an interest in honest reporting about the facts of reality, and so we would say everyone ought to join in. Except maybe the creationists and the flat earthers. Okay, they can stay home. But
okay, the flat earthers, yes, especially the flat earthers. My goodness. What about the Scientologists? Are they allowed? They've got science in their name. They put science there. And
now you're getting into the difficult questions. Actually, the thing is, as I said, we don't want to start policing who's allowed. So if a creationist wants to join the march, we would disagree with them on many things, a great many things, but okay, please come along and make your voice known. Same for, people who have differing views on little bitty things in scientific theory, that there's a lot of that going around as well. Those darn people who disagree with me about the importance of neutral evolution. Should we ban them? Nah, I guess we let them in. The march will be, it will liven up the march if we have people we can argue with as we're walking along.
Right. Shall we bring our battle axes?
Yeah. That would really be representing science if everyone is bickering as they walk down.
No, this is science. Well, I'm hoping that everybody can drink the holy wine of rationality from the chalice of science and maybe it'll burn out all the impurities and get them all thinking sort of along the same lines. I mean, the
Ah,
scientific method is important, though. I mean, when people think about how it works, it's not all that like. In fact, it shouldn't really be considered as a separate magisterium from just rational thought, too, right?
oh, I
Um,
agree. Yeah. You know, and I often make the argument that even if you do talk to creationists, okay, maybe not flat earthers, but creationists at least, they are, you know, unconsciously endorsing scientific thought. That if you listen to things like Answers in Genesis, Ken Ham, all that stuff with the Ark Park and this Creation Museum, it's bizarre because they are making bad arguments, but they're bad arguments based on their perception of science. You know, they could short circuit the whole problem by just saying, well, the Bible's full of miracles. This was a miracle. God did it. But no, instead what they have to do is invent these implausible scenarios where you have these causal relationships over time to cause these events. And it's not just God willing it, it's you've got to have a source for the water for the flood, for instance, and you got to have mechanisms for dispersing the animals afterwards. You can't just have the old guy snap his fingers and do it. So it's, you know, there's hope that
yeah.
if we keep pressuring that, and if they keep pushing this idea that you can't just rely on miracles, we're actually undermining their views, and then they're undermining them on their own.
Yeah.
So,
I read an interesting report. There was a 10-year study, or something like that, on decision making, cultural cognition, or something like that. And what it showed was that people, even if they were using, you've heard of Kahneman and Tversky's System 1 and System 2. System 1 is the fast sort of thinking where you use all these heuristics that evolution might have sort of programmed into you, and System 2 is more to sit back and consider and be rational about all this sort of thinking, right? But
right.
people were using, like smart people still use System 2 thinking in order to justify their priors or sort of support the community of beliefs that they belong to, instead of actually trying to nut out what is real and what is true. Um,
Yes.
mm,
And scientists are really good at that. You know, that
mm,
scientists are great rationalizers. And that's basically what you're talking about. Is what they're doing is not so much using their prior knowledge or set of observations and confirmed facts to derive a conclusion. They're starting with their conclusion. They're trying to fit the facts to rationalize that conclusion into some kind of scientific version of the truth. And we all do it.
mm,
Creationists do it too. Evolutionists do it. We're all sitting there trying hard to put together a coherent worldview.
mm,
Ultimately, that's kind of the goal of the human mind, is to have something coherent and self-consistent, and we can go in multiple directions to do that. And one approach is, if you've got something outside of you in reality that conflicts with your view, just discard it, ignore
mm.
it, pretend it doesn't exist. Scientists, I think, ideally try to say instead, no, we got to bring that in. We got to compass that in our worldview. How can we do that? And sometimes our brains break when we do that.
Yes, brains are fragile,
Yes.
especially
Yes.
mine at the
Brains are
moment.
relatively simple compared to the complexities of the real world, which makes for a serious conflict.
Hmm. And particularly, what we tend to do, it seems as though, is when there's a little bit of uncertainty, we try and fill it in with beliefs.
Yes.
Often, mysticism in the past, and I guess rationalize based on. Well, I guess it's good to rationalize based on real evidence what could be existing in these sort of gaps in our knowledge. But let's talk about dealing with uncertainty
Uh-huh.
in science. Try to I guess strategize and deal with like aspects of uncertainty in the real world. I don't know how
Yes,
best to phrase that question at the moment. I'm sorry.
it's
An uncertain question.
well, this is something we do all the time, and there's kind of an ideal way that a scientist deals with uncertainty. So you've got an observation, you've got an idea about how it works, but there's ambiguity, there's uncertainty, and the true scientist would say, well, then what we do is we go make more observations and do experiments until we narrow our options enough that we have one choice to follow. We can often do that in the laboratory or in the field if we're doing research on scientific issues. It gets harder when you start dealing with political issues.
Mm.
Suddenly, the range of variables is so huge that sure, we can dismiss this little collection of variables over here, but then there's all these other variables over here that keep on introducing uncertainty. And it's probably impractical and impossible to eliminate all of the variables, get down to the one thing. But yeah, that's the ideal, is let's do it that way. As you mentioned earlier, we all have heuristic shortcuts that let us get to ideas without trying to do everything at once. And one of the things we also try to do as scientists that's harder to get across is we try to develop heuristics that have proven value and that work fairly well most of the time and get those across to people. And that's another thing that's really tough to do, especially if you've got somebody who's got a load of priors built into their brain that conflict with your methodology.
Mm-hmm. And the amygdala is a pretty big prior, I guess, there's a train, the sort of thing that, great for helping out memory and things like that, epistemic memory. But yeah, I've heard some researchers that people who sort of system one thinkers or whatnot, predominantly, that part of their brain lights up, and people who try and strategize through things a lot more often use their frontal, this frontal part. I don't know.
Right.
Pretty interesting.
Yeah, you've just mentioned another scientific heuristic, though, is that
yeah, it is.
parts of the brain lighting up. Mm-hmm. Do I believe that? I don't know if I believe that.
There's actual light globes. They found them, didn't you know? In the brain.
Okay.
Mm-hmm.
Yeah.
I've got a few, but they've all broken. They need replacing. So.
Right. Yeah. No, I just think that that's another example of a shortcut is say, okay, well, let's just say let's deal with it in a reductionist way. Here is this part that's responsible for this function over here. But I think when you look at the brain as a whole, what you discover is all the parts are contributing to this in complex and relatively different ways. And I worry about, so one of my fields is neuroscience, and I worry kind of that we're busy, painting ourselves into a corner with a lot of that stuff.
Right, yeah, making bold claims, yeah. I guess, to some level, it helps people think about their minds and helps people visualize what's going on. But it's not. But this abstraction isn't really the whole truth, really. Yeah,
right.
Not even sometimes not even the truth. It's just a story which helps people understand or put things into place, which might not, be a very good pointer to actually what's really going on. So the map doesn't. These maps are faulty children's maps that aren't really relating directly to reality. Yeah.
Yeah, but stories are important. Story, in science, you got to have a story to tell. That's right. That's what I've been hammering on my students this week. They're giving presentations, and I've been telling them, yeah, it's fine to recite the facts, but unless you get a story to help organize them, nobody's going to care. And this kind of modeling of how the brain works is a prime example of scientists creating stories to sort of add structure to what we understand. Because catalogs of which regions of the brain light up are really boring. Don't tell you anything.
Coming down the little rabbit hole we've just sort of burrowed into for a little bit, what do you think of the future then of what's possible in understanding how the brain works through, I guess, like scanning, like fMRIs, like a scanning what the metabolism, magnetoencephalography, very expensive machinery there, seems to be able to dig a bit deeper. But yeah, what are your thoughts?
Oh, let's see. fMRI is hot right now. So I
Again,
hate to, yeah, it's really bad to criticize it because you're kind of digging your own grave if you do that. But but yeah, I think there are pieces of the story, and I think fMRI and all this other, magnetic stimulation, all kinds of other ideas like that are useful pieces of this story, but they're not the whole story. And that's my concern, is that we get focused on one thing. Uh, for example, when I was a graduate student, I remember we all had this great envy of this one lab in our building. They were doing neurochemistry, neuropharmacology. And for them, an experiment was they'd use these custom designed electrodes and they'd lower them into a rat brain, recording as they went, and reporting back what neurotransmitters are present at each level in the stereotaxic device that they had hooked up there. And they'd pull it out and they'd go write the paper and publish it. It was a great racket as far as I was concerned. I mean, sure, I wish I could do that, but it was a case where a new technology comes along that is valuable because it's a great way to generate data. And they definitely were generating tons and tons of data, but I lacked the understanding of what they were trying to get at. That at some point you got to step back and say, okay, here are these 500 papers we've published in the last couple of years. What does it all mean? And what's the story behind this? And I missed a lot of that in that person's work. And I think things like fMRI are the same thing, where this is a fantastic technique that just pukes up data and volumes and volumes of data. What do we make of it all, though? And I don't have a coherent picture yet of what you can say about how the brain works from these little pixels lighting up in an fMRI image.
Mm-hmm. Mm-hmm. Mm-hmm.
It's going to take a grander theory to integrate these all and put them into something that makes sense.
Do you think we can sort of make sense of it with information theoretical approaches, like a statistical sort of representation of what's going on, and trying to work, I guess, push the boundaries of our knowledge that way?
That's possible, and I have been thinking lately that may be necessary. That what may happen is that the human brain is not big enough to understand the human brain, right? Mm-hmm. Obviously.
Right.
It's going to require some kind of new technique that involves not so much human thought as machine thought.
Mm-hmm.
So some kind of elaborate statistical analysis that will extract, a digest of the information about how the brain works. There's
network of what's going
on. Yeah. There's all this cool stuff now about for instance, computers designing antennas just by glomming pieces together, and you get something that works, and it just keeps adding and subtracting until it gets this real world element that actually works effectively as an antenna. And everyone looks at it and they say, we don't understand how that works.
Mm-hmm.
You can't. All you know is you plug the cable in here and magically all this signal comes pouring out, which is what you wanted in the first place. And I kind of suspect that's what's going to happen with brain science. Is we're going to take all this data, we're going to dump it into a computer, and then we'll ask it a question like, what's this person's favorite color? And it will spit back blue, and the guy will say, yes, it is. We won't know how he got the answer, but
it's kind of like asking Deep Thought, from Hitchhiker's Guide to the Galaxy, what's the meaning of life? And
right.
You get an answer you don't understand.
Yes. Limitations of the brain. I think we have to realize that those are there.
Yeah, skull bound. That's what we are.
Yeah.
Well, talk about like facts and maths and territories, and let's talk about like alternative facts and alternative maps and not alternative territories. There's only really one. We should all agree that there is actually one physics, at least in our universe, that we should all be paying attention to. But these alternative facts.
Yeah.
Kellyanne Conway and Sean Spicer and Donald Trump seem to be saying, like, trying to present a different reality to the public.
Yes. And it's exactly.
Look, I don't know. I can only guess it why, and like it to me it really does sound nefarious. But
Yeah.
I'd like to hear your.
So it's what we were talking about earlier when we were talking about rationalization. Is this is a group of people who have a very fixed worldview, who have this perspective on here's how the world works, and what they are doing is they're trying to find a way to deny the existence of facts outside of that worldview. And that's what they mean by alternative facts, is we need a set of data that we've invented to fit with what we want the data to say. So, in a sense, this is anti-scientific, because that's not what scientists should be doing. They should be modifying their theories to fit the evidence, not modifying the evidence to fit the theories. And that's exactly what they're doing. It's a very dangerous sort of attitude to have, because it's ultimately destructive to science if this is endorsed. We would get nowhere if every scientist could have a pet theory and just say, I'm gonna say that that the facts must be this. So yeah, it's a very dangerous thing. It worries me a lot that it's actually accepted by our administration. And media, well, the media is kind of noticing that this is a lot of bullshit, but they're not doing a good job of fighting back against it.
How should the media fight back against it? How should, is that different from how we as individuals should? We as a group of people?
Yeah, well, it is, because when you watch much of the news media, you begin to notice that they've got a party line that they're sticking to, and that there's this attitude of deference to political authority that doesn't allow them to challenge it. I mean, we're starting to see cracks form there, because, man, the Trump administration is really distorting reality, and it's becoming hard to avoid confronting it. But what you often see is, instead of actually coming out and saying, President, that's bullshit, you instead see either attempts to understand where they're coming from. Why are they saying this? What kind of argument are they trying to make? Are there actually alternative facts that they know about that we don't know about? There aren't. But the other interesting thing the media does is they have resorted to treating the news as more like theater criticism. That instead of saying, well, the content of this argument is bad, it's wrong, this is a false fact, they're instead talking about how well it was presented. That's also very disturbing. We saw this with Trump did a speech yesterday, which I completely avoided. But now the big message in the media is he did so much better than we expected. They're not judging him on the content of what he said, but on their expectation of how he would say it.
Oh, okay. Right. So he was probably prepped and had a few speech coaches behind him this time. But it doesn't get away from the fact that the content is probably like, well, I didn't watch it myself, so I don't actually know. But we should be focusing on the actual content and the policies instead of the prose and the rhetoric.
And that's where alternative facts comes in very conveniently, is because if all you do is focus on the style of the presentation, then it doesn't matter which facts you bring in, whether they're false or not. It's all a matter of what's the guy's performance like. did he present this persuasively, or did he do a bad job? And that's not where we should be having our discussions. We should be talking specifically about the data.
Right. Yes. This is not a Toastmasters like analysis here. We're trying to be. We're trying to actually search for the truth of what's actually really going on in the material or the physical world. That's what science does. And then with engineering, we can use the knowledge and the structure we have from the science in order to sort of engineer interesting things and solve problems.
Yes.
Yes. So yeah, this whole I spoke to John Wilkins recently and had a little interview with him, and we discussed epistemic relativism.
Okay.
So I mean, like relativism. Okay, so
Yeah.
we'll discuss like what relativism is. It's really just if you have a point of view, then that's just as relative as another point of view. So you have cultural relativism, moral relativism, and epistemic relativism, which is another
Yes.
form, I guess, they'd all fall under.
We have different ways of figuring out what the truth is what he's trying to argue. Yeah. Okay.
Yeah,
Yeah, that's a philosopher for you.
yeah.
Trying to put an interesting twist
He's a
on.
taxonomist, right? He always tries to fit things into categories, yeah.
Yeah, there's a lot of validity to what he's saying. That on one hand, you could say that it's just relativism, that we've got different communities that have different perspectives, and they're interpreting the evidence in light of their prior understanding. That's the most benign form of relativism I could imagine.
I don't think John was arguing for that, by the way, just to be clear here.
Oh, I wouldn't think he would. Yeah, it's just that this stuff gets really tricky because it tends to put a mellower perspective on what they're doing. That we could look at this as, and again, I don't think John was doing this, but it tends to put a rational perspective on the irrational, which isn't necessarily valid. That we could sit here with a scientific relativistic view and say, well, under some frames of reference, we could argue that maybe the world is flat, and have a fun hour arguing about ways to interpret geographical information. But it would require ignoring a lot of other evidence that says, no, the world is roughly spherical, and it requires distorting and leaving aside a big chunk of evidence in order to argue that it's flat. And I think that's also one of the concerns with science, is that so often when we're dealing with unscientific views, what we find is people who argue from a small piece of the story, who pluck out one fact, and yes, that fact is true, it is correct, they have this piece of evidence, and they can interpret it the way they want to, but only by ignoring these 10,000 other facts behind it that are giving you a more balanced view that says, no, you're thinking the earth is young or flat or whatever is an untenable perspective.
Mm-hmm. Yeah. So it is interesting that people feel so, I guess, viscerally connected to these modes of belief, things that they've grown up with. Sometimes people believe that, they should just, I guess, lobby for an idea that underneath they don't actually believe themselves. Some people, I'm quite sure of it, some people who go to church and who try and do the religious thing don't really foundationally really believe it, but they believe it's good to believe it. Because
exactly.
It's some sort of like communal thing, right?
Yeah, we're seeing a lot of that conflict in the US right now, because we've got all these people who voted for Trump who's got really anti-poor person policies, who's trying to harm people who aren't well off. And when you try to explain them, it's kind of the opposite of what Jesus was endorsing. How can you do that as a Christian? And they don't quite seem to get it. You know, you get the feeling that they really fundamentally, most strongly hold this view that they're anti-freeloaders, not so much that they're deeply Christian, which was for the poor, help the poor, and they, at the same time, though, of course, want to claim the mantle of Christianity, so they're not going to admit that.
One of the things that people have a problem with is how science might change over time. Well, theories might evolve or progress over time. So updating theories based on new evidence, people think, well, if science is real, and you know, like people at the Science March are holding up science, saying science is real, but the theories change over time, and people might get disheartened by the fact that, well, I thought that this was the model we had to believe in, you know, and it suddenly changed, right? So, like, for instance, you know, Newtonian physics wasn't like the whole story, or yeah, there was quantum physics as well.
Right. You know, that actually gets, I suspect John must have talked about this, but that to science, what's often more important is not the raw fact, you know, the observation you made that says this bottle weighs 12 ounces or whatever. It's the framework that you put it in. It is the theory. And it's also this general idea that the ideal of science is to constantly revise your theories so that they're better descriptions of how the world works. So we have this kind of deep commitment to modeling the world as well as we can. And that's what hasn't changed. That stays constant. It's just that, you know, in order to do that, we have to track the new data that comes in. And so we happily modify our prior conception of this. What it is that science is kind of rigid in one way, and saying, yeah, this is an ideal that we try to model the world, and yet it's extremely flexible in a way that many people find uncomfortable. That model is what we're happily going to change. It also goes back to how human minds work. You know, the mind is a great modeling instrument. So it's modeling how the world works around us. And what science does is say, well, you should change your mind. Change it frequently. It's a good thing to change it frequently. And a lot of people would rather not do that.
Mm-hmm. It's difficult to change one's mind. I mean, our minds were, I guess, like I do look to evolutionary psychology a little bit to try and understand how I work. And my unwillingness or laziness to sort of think about things over and over again and renew my beliefs. But I try to. It's just difficult, right? We evolved to use a whole heap of heuristics in order for our ancestors to spread their genes in the ancestral environment, the
right,
and so on.
Yeah, but you know, that's another good example is that we often start off. You know, so here I am doing evolutionary biology. We often start off, in the beginning at least, with this idea, oh, natural selection, right? That it's shaping our genes and it's changing the frequency of genes, particular alleles in a population, and that's how evolution occurs. And then as you get deeper into it, you start discovering that that's kind of a simplistic model, that doesn't describe everything. So for instance, right now, this term I'm teaching a course in ecological developmental biology, and we're just sitting there going all around plasticity and niche construction and all these other models that say, no, we change the world around us in addition to the world changing us. And it requires thinking about stuff in a very different way. I'm also teaching a course in genetics, and maybe that's even a better example. Is this is an undergraduate course in genetics, and Most students come into this thinking they know genetics, at least the basics of genetics, fairly well. And what they know is simple Mendelian genetics. Not even on a complex level, just simple Mendelian genetics, single traits and how they assort and all that kind of stuff. And the first lecture I gave in that course is to tell them that Mendel was wrong about everything, and that's not how genetics works. That it's a starting point, that it gets you going. But once you start, what I'm going to be doing is I'll explain Mendelian genetics to you in the first week. It'll be a kind of quick and easy review. And then the rest of the semester I spend showing you how it's wrong. Because that's what you have to do to understand genetics. That right away, you've got Mendel's laws of assortment and segregation, and the first thing you teach them after that is linkage, which says Mendel got it wrong. that traits are modified by their association with others, and it just gets hairier and hairier as we go along. And but that doesn't mean that we throw out Mendel. Mendel's still a great way to start with the basic concepts and get you thinking, okay, and for Mendel's time, that was a revolution in how we thought about heredity. So it's a good place to start, and you just have to recognize from the very beginning that it's never quite this simple, never quite this clear-cut, that what we're going to describe is all these other things that influence it and change the way inheritance works.
Mm-hmm. So I guess a lot of the participants in the Science March who aren't scientists will be coming in to the Science March with, I guess, their own ideas about what science is. And, there are concerns that some people will try and co-opt the Science March in order to, yes, will make it sort of agree with their priors. Now, I don't know if there's anything we can really do to stop that, and I'm not really interested in sort of policing it like you said. But what can we do to sort of increase people's receptivity to science and, I guess, bias the likelihood people are going to walk away with a good message and a useful message about science that they can use personally in everyday life, but also representing some emblematic, useful message of science at a more of a community level, politics perspective.
Yeah, that's a tough one, because I would say that one approach you can take is the one that Bill Nye is taking. You've heard of Bill Nye down there in Australia, right? Yeah, Bill Nye, the science guy. He's now actively arguing on behalf of science, and his approach always boils down to one simple thing, and that is science works. Science leads to improvements in your lifestyle. You need to be educated to do science, and the foundation of American success is scientific and technological. So that's one approach. It's a very pragmatic approach to say, why do we care about science? Because it gave us cell phones, right? That's the whole point of science, which I kind of disagree with in principle, but still, for the great masses, it's a smart, productive, useful way to get them to focus on our concerns.
Mm. So that's gave us germ theory and medicine and things like that, right?
Yes, your grandma lived another 10 years because of science doing this thing. We're seeing gradual improvements in recovery from cancer thanks to science. These are all reasons you should support science. Another approach I think we'll see at the March for Science that worries me a little bit, although I'm selfish enough to think it's a good idea, is just working for science funding. We're worried right now that Trump has announced this new budget that's going to have cuts of 10% along on everything except the military, which gets more. So one argument is we're going to be out there saying we got to defend our source of money and the independence of things like the NIH and NSF. So that's another purely pragmatic approach. I don't know how much success we would have if we went out there marching and saying, we are here to endorse your ability to change your mind every once in a while. That just doesn't grab people. So as far as strategizing goes along those lines, I'm kind of unclear. The approach I take, to argue about the importance of change and adapting your theories is something that works well in an academic environment where I can sit down with students and we can discuss these things at length. One of the other realities of the march is it's going to be a march of sound bites. We got to have snappy sound bites on our signs.
Science, not silence, is a soundbite going around the March of Science organisers at the moment.
Yeah, and that's just another compromise we have to make. It's not reflective of very well of how science works, but it's how we reach the general public, and that's kind of important as well.
Someone in the channel asked about the role of citizen scientists. A citizen scientist, not necessarily being part of an administration, might be a credentialed scientist, but citizen scientists getting in and getting involved. I just simply ask, how can citizen scientists contribute?
Well, as I mentioned earlier, there's not any kind of prohibition that says you have to have a degree or a position at a university in order to be on the march. So I would hope they would be joining in. That a lot of sciences depend on citizen scientific participation. Astronomers, of course, it's a big thing. That just having masses of people out there making observations is actually a useful contribution to astronomy. It's also an important contribution to things like ecology. That shortly we'll be having this day around here where you go out and record frog calls. We do our frog population assessments, and that's citizen science all the way. And also I would say that, as I was talking about earlier, if science is this principled theoretical set of ideas about how you view the world, that isn't necessarily restricted to people who have high-paying government jobs and have $5 million grants. So we want all of these people to be participating.
Okay, well, yeah, I haven't got any other questions other than, have you got any final sort of wrap-up, sort of all encapsulating, not tying, bring everything together thoughts or statements? What good takeaways that people can remember from this interview?
Gosh, good takeaways. Oh, you want something short and
takeaway science. Fast science.
I would say that one takeaway is that good scientific thinking and activism are not incompatible. That we should appreciate the fact that these two complement each other and they can work very well together. What we want is more science activists, and the Science March is one tool to bring those out.
Excellent. Well, it's been fantastic having you on the show, PZ. And I look forward to speaking to you again in person, sharing a beer and having discussions about all weird and wonderful things like transhumanism and artificial intelligence.
There are many arguments. Do we have a couple more hours? Yeah, no, but yes, and those arguments are best made over beer.
Maybe in another podcast, we can sort of discuss that. And I have noticed a couple of your posts too, and I think there's some of what in them that I actually, some of the information there, I do agree with some of the opinions. But I do think transhumanism, in a sense, I think you've said this, is inevitable.
Yes.
In the sense we're going to evolve. Oh, actually, it's not inevitable if we go extinct. Well, now that's one thing I did want to discuss, which I forgot. And everybody, sorry, you're not allowed to go yet, but you have to hear this. What do you think about trying to avoid extinction or local catastrophic risks through, listening to what the science has to say?
this is a self-interest thing. Of course we want to avoid extinction. We can't help but want to avoid extinction. I've got family. I like them. I would like them to stay alive as long as possible. Um, so it's a strange question.
It
Should
is.
we resign ourselves to the inevitability of our demise? And I think we ought to appreciate and recognize that yes, someday the human race will go extinct, or someday the human race will change to the point where it's unrecognizable to us now. And we can go down kicking and screaming, but we can't exactly say, no, this is not going to happen. That would be a simple denial of the facts, which we've just said we're opposed to.
Right. So either in the long term, if we don't go extinct, the human race will evolve into something which is taxonomically different, right? As if the universe is sort of divided up into some sort of like taxonomy anyway. But yeah, sure, it'll look different, it'll be different, even if we don't continue to technologically like advance and sort of intervene in our biology.
Yeah, I would also say though that the transhumanists are right that technology is going to change us rapidly as well. Where I disagree with transhumanists is that they think they can predict ahead of time what the right way to take is. And I think the actual fact of the matter is that technology will change us, and it will change us in ways that horrify us now, but are very gratifying to our descendants.
Well, actually, yeah, I agree with that. I've got a friend, David Pearce, who theorizes about trying to keep in mind that there are a lot of depressed people and a lot of people who spend life, I guess, below average hedonic sort of tone, and yeah, that there's scientific ways to intervene. I've heard of some lady who's got some sort of dopamine in a machine in her brain or something like that. I don't know the details, but she feels better because of it. There's no denying the fact that she's been benefited from sort of a weird but interesting bit of technology there.
Yeah, and there's so many ways that we voluntarily modify our brains right now. I'm drinking a caffeinated beverage. I have my coffee every morning. I am changing my brain with technology every single day, and I like it. So that's going to continue, and it will accelerate as we devise new technological ways to shape how we work.
Right. But if, for instance, we did go extinct, then not only our children and their grandchildren, wouldn't have a life to realize, but countless people, if we go into space, we get off this planet, out of this gravity world, then there seems to be, as far as I can see, a lot of inert matter that isn't being sort of appreciated by any humans or creatures with the ability to, I guess, have raw experience about phenomena. And it would be a shame if there were none of that in the universe, right?
Right.
As far as I can see, there doesn't seem to be any expansionist civilizations hanging out in the galaxy, at least in our cone, cone. Sorry. So if we go extinct, then that could be a massive part of the universe which is, in a sense, dormant. That seems it seems like a shame to me.
Yeah, that's an interesting perspective, though. But I mean, does the rest of the universe need to be appreciated?
Maybe the universe in itself doesn't have a need until it has conscious creatures like you and me, with a sort of a level of a modelly, it's sort of agents that can experience and have sort of raw experience about the universe.
Yeah, but that's what I mean, is the entire locus of valuing the experience resides here in our brains. And if our brains cease to exist, then there's no longer any reason to appreciate other things.
Yeah.
So who
The
cares? The
reasons
universe,
disappears, right?
yeah, the
So
universe will stay alone without us.
that's right. The universe will go along, but like if you were like God, for instance, and you had the ability to press a button and just shut everything off, would you do that? I mean, like to wipe out all life painlessly, including yourself, in God, would you do it?
That's an interesting question, and I would definitely say no. That even if I were that kind of deity who is now facing my own extinction, I'm about to go, my essence will disappear. I would still take some consolation in the fact that this creation I made is going to continue on afterwards, even without me there to see all of it. Even if it is just this human race on one planet that's going to miss all the great stuff going out there in the Andromeda galaxy. Um, you'd still want it to go on, or at least I would.
Yeah, I get that sense too. And so by omitting, like, I mean, it's one thing to be able to sit there and press a button, but what if the mechanism was if you don't do anything, then it's just like pressing a button. I mean, not doing is that results in a horrible outcome. It's the same thing as doing that results in a horrible outcome if you're outcome oriented. Then yeah, it seems as though the logic to me is if we value this this human ability, not necessarily only human. I think non-human creatures might have the ability to enjoy life as well. But if all that was sort of extinguished, then it seems like if I had the ability, if I had the means, I'd try and make sure that doesn't happen, and therefore try and avoid the extinction, regardless. So, in a sense, my care for future life doesn't just expire at the whatever the expiry date of my grandchildren's life are happening.
Right. Yeah, we have to be willing to work for it as well, instead of just passively enjoying it. And yeah, I can sympathize with that. That's, I mentioned earlier, you can be a scientist and you can be an activist. An activist is somebody who is fighting to maintain something or to improve something. And that's what I would like to think we would do, is we would continue struggling to maintain.
Well, I mean, like, if we look at climate change, I mean, there's no doubt that, like, if climate change did get so bad that it sort of, wiped out a lot of life and perhaps even extinguished, like, human life, through the process of that happening, there would be a hell of a lot of suffering involved and a lot of displacement, and, perhaps even take many generations for that over which suffering, immense suffering would happen. That's something I'd certainly like to avoid, regardless of the fact whether I had the chance to sort of, I'd also try and try and avoid the suffering. I think that's a benefit to trying to avoid extinction as well as trying to avoid extinction because we want life to continue in the universe. Yeah.
Yes.
That was a good way to say.
Yes, and I can sympathize with that as well.
All right. Well, yes, that was an interesting conclusion there. Maybe we can talk about that another time.
Yes, we have agreed that we do not want us to go extinct. So
Yes.
that's a plus.
Well, yes, let's rally for science and let's do whatever we can to increase science advocacy and to increase the influence of science on political thinking and try and steer the science march in positive directions in any way, non-policing, being inclusive and everything. So yeah, I guess summing up what you've just said before, what if a one-liner, like a one-line closing sentence, what would that be?
Keep fighting for science. That's what we're doing.
Fight for science. Keep fighting for science. I agree. All right. Well, thanks, Heath, and I appreciate your time.
Thank you.
And speak again sometime. Cheers.
Very good. Talk to you later.